Meanwhile, I'm over here trying to figure out JWTs. JWTs are really simple. They are made to seem overly complex, but you know, it is essentially, it's just this. That's all it is. You got some base 64. So let me go the other way. A to B, no, B to A, B to A. So we're going to take something here. Actually, we're going to do it this way. Yeah. So I'm just going to throw some stuff in here because I don't remember off the top of my head exactly what it's like. But there you go. Now you've got something base 64 encoded. All right. But you get rid of the equals, and you also change a couple of other things, but I'm not going to get into the details there. We're just going to keep it simple. Okay. So now we're going to have some arbitrary claims. Sub is usually what you use as the username, or the, not the username, but the user's pairwise identifier, meaning that it's not the ID in your app and it's not the ID in the other app. It's basically a hash of the two. So, let's just say there's our sub. And then you take a signature. So for lack of a better way of doing this, let's just say crypto, let's just say we do this. var JWT. Okay, there's half of it. Whoops. Sorry. The one more thing that we need to do is add a little dot in there. I'm doing a terrible job at remembering to use my backticks. All right. So there's the little dot in there. And then you're just going to take that and you're going to add to it. Well, you're going to do crypto dot subtle dot, what is it? Oh, this is a good one. I'm going to turn the volume up on this for myself. Which way is up? Okay, I'm not going to go through it right now, but basically, because I don't remember where it's at, it might be under digest. But basically, you just create a hash of that with another value or a key. That's it. That's a JWT for you. Now, the spec of what things are called and what, all that, best place to look that up is OIDC errata core 1.0 incorporating errata set 1. And then, was it claims? Standard claims. There you go. This is kind of the most important bit right here. And I'm going to reread those comments that I've been ignoring while I've been babbling on. There you go. Boom. So what you can store is the JTI, the identifier of the JWT, and that will allow you to blacklist tokens. But you should always set an expiration date on a token. Here's the strategy for JWT authentication. There are two claims that are well known. One's called exp for expires. The other one's JTI, that are really useful. What you want to do is the token that you give the user, say in the web app, you want it to expire after about 5 or 15 minutes. And you want to be rotating that constantly. That's a good short value. When they go to exchange their current token or their session token for a 15-minute token, because you're going to have two tokens, basically the refresh or the session token, as well as the access token that they're using continually to access the different parts of the API. When they go to exchange that, you check in the database to see if the user is still valid and has the right permissions. So at the longest there, you're only going to have a 15-minute cycle between when you revoke their permissions and when their permissions are actually revoked. If it's a security-sensitive application where you need to be more mindful, you can use the JTI, which is a random identifier, and then you can store that in your database. And every time a token comes in, you can go look up the JTI. And if the JTI is not in the database or is marked as invalid in the database, then you reject the token. And then you can have instantaneous rejections. Does that help? So the answer to the question is it depends on the use case. The original question was, do you prefer to compute or store JWTs when verifying? So wait, it's literally plugging JSON into crypto functions and encoders? Yes. Yes, that's literally what what JWT is it's just the header. If the header is part of the signed, terms are a little bit overloaded here, so I'm trying to use the right term, data. If it's part of the signed data, then the header is called protected. So when you decode a JWT to JSON, it's called a JWS, a JSON web signature. A compact or compressed JSON web signature is when you take the JSON and you encode it to base 64. Now, because of how you want to verify you end up doing that anyway, because when even the JWS actually still has base 64 inside of it, and the reason for that is so that you can compare signatures more easily, because otherwise you have to define how to sort order the JSON keys when you do the signing and the comparison. So it's always, whether it's a JWS or a JWT, it is always it's always base 64 encoded, each of the parts. But if you fully decode it, you get a JWS that has a header, which is the JSON, protected, which is the base 64, claims, which is the JSON, and then payload, which is the base 64, and then signature is always base 64 because it doesn't decode to JSON, as binary. All right, that JWT explanation was super helpful. I've been dealing with Julia not having well-maintained JWT libraries, so hopefully I can bypass that with this knowledge. Yeah, JWT, where it gets tricksy, okay, because at the surface level, JWT is super simple, and people just need to know what it is. They don't need to know all the millions of things it can do. They don't need to know how great it is. They don't need to know all the enterprise buzzwords. They just need to know it's a text format for encoding JSON and then using a well-known signature algorithm on it. But where it gets complex, because you think, oh, well, this is easy. I'll just code this up by hand real quick. Guilty as charged right here. But what happens is that then you have to deal with the expiration, and then you have to deal with which signature formats do you want to allow, and then you have to deal with which variations of those signature formats do you want to allow. So if you're doing JavaScript, I of course am going to recommend my own libraries, key pairs and key fetch, for dealing with JWT, because I think that they're the best and I wrote them to be the best, but for my use case. But I think if you're not following my use case, then you're doing JWTs wrong, because there is too much leeway in the spec. And so the way that I do it with KeyPairs.js and KeyFetch.js is more narrow than what the spec allows, which is what you should do. Because you don't want to handle everything a JWT can do or be, because you will run into security vulnerabilities and either making things overcomplicated or making them less secure. So there's that.